at Citi. Right now I am head of customer strategy for Ionic, but prior to that I was at Citi for 9.5 years, where I ran security strategy and standards for both enterprise and consumer, the bank. It was easily the greatest job I've ever had, with the most responsibility and the farthest reach. Every day I got to sit, and in addition to my team writing the standards and basically how the bank would operate from a data security perspective, but on top of that, I got to define the strategy, where we were going to be in the next 5, 10, 15 years. I had a great team, I had amazing mentors, and visibility at the highest levels of the bank. To talk about what made me leave, we have to go back a little bit. And this is just a disclaimer, this next slide is not pretty. That was me, 1989, when I joined the Air Force and got my first taste of cryptography. I was working on F4s and A10s, and part of the job was to every morning take the keys out of the vault, load up the communications, and identify friend or foe systems for the sorties of the day. At the end of the day, we'd zeroize out the planes, and we would take the keys and effectively revoke them. What that really meant was putting them into a coffee can and lighting them on fire. So that was almost 30 years ago, and key management has not really changed that much. It's digitized, but it hasn't really gotten any better. Since then, I've spent most of my career focusing on cryptography and identity, essentially trying to enable the business, trying to get businesses to be able to use their data while keeping the data safe. To keep the data safe, you have to encrypt it. To encrypt it, you have to deal with keys. So essentially, whatever the solution was, whether it was for securing online payments or email or healthcare records, it was always about key management. It was always about encrypting and or decrypting the data under the right circumstances. Eventually, when I made it to Citi and started working on that job, I found out what it really means at a large, large enterprise. So, as my boss is telling me the things that I need to take care of, it essentially still boils down to key management, but key management at a massive scale. We had thousands of commercial off-the-shelf software and thousands of customized applications, as well as completely homegrown applications, built by over 40,000 developers with scores of regional regulators in 108 or more countries. It was a massive undertaking. And within that, it was things like publications and reports, internal and external secure collaboration, mobile, cloud, secure storage, custom apps, everything. All of that was my job to solve from a strategy perspective. Nothing big, right? Well, doing what any good security person did, I first went to our policies and our standards. And I started to look at how good they were and to change them. So we changed our standards and made them pretty much bulletproof. I mean, they told you everything you needed to know. Key sizes, algorithms, hashing, where to store your keys, how to use the keys, what kind of data needs to be protected, how it has to be protected, how long you have to keep it, all the good stuff. Dishes are done, right? That's it. I got a policy. I shouldn't have to do anything else. What it turns out in reality is what happens is somewhere within the institution, something has to get done, right? An app owner wants to make money or enable something within his app. So he says, hey, I'm going to do this cool thing with social security numbers, for example. And security says, oh, that's awesome. You should totally do that. Here's the policy. You have to secure it. And after being sworn at a lot and given some obscene finger gestures, they go off and they either talk to their vendor or the application engineers and say, security says I have to secure my app. Can you secure this? And if it's a vendor, they'll say, absolutely, sign this. And if it's your engineers, they'll ask for the policy and they'll go do it. What that really means, though, is crypto and data protection tools are built into the application. And even though the policy says how to do things, there is still room for interpretation. And so the individual developer is looking at things like encryption algorithms and hashing and key size and random number generation, all of that. And on top of that, it's where do you store the key? And most likely, you're not using HSMs because there are thousands and thousands of apps, and that's a lot of money. So they have to store them in software. Well, policy says you can't store a key in the clear in software, so you have to encrypt it. So, okay, well, I'll encrypt it to a password. All right, where are you going to store the password? Because you can't store a password in the clear. Oh, well, I'll encrypt the password. With what? It goes on. And they go, okay, well, we'll use a secure vault system that you can buy that stores passwords and applications can check them out. Well, how do you authenticate to that system? Oh, well, we use a password. So you end up with this catch-22 of either keys or passwords, some form of another, being stored in the clear. There is no real solution for that at the moment. So within large institutions, there's usually waivers for that. There are ways to get through it, but it's difficult and ugly. One-off, that's not bad, right? I've contained my data, right? It's inside that app, so it's secure. Does your data live in that app only? Is it created, used, and die there? No. Your data goes everywhere. It's in BYOD, it's in mobile devices, it's in cloud, it's in hybrid cloud. You have applications sharing data with each other. You have users exporting data to manipulate in Word or Excel and then importing it into another application for reports. Your data is everywhere. It doesn't live in that little box. So why do we spend all that money just on the little box? And right now we're just looking at one app, one little thing. If we scale that up to even a small line of business, we're looking at maybe 14 little things. 14 little places where I've had to spend money and resources individually designing and implementing these security walls to contain my app. They're secure. The data is secure inside those containers. But is it enabled? Are you getting the most value out of it? I don't think so. So if we step up a layer in the organization, I realize that looks complicated and it's supposed to demonstrate the scale of a large organization like Citi. It doesn't. I tried to do it accurately and I broke PowerPoint, so I had to scale it back down to a much smaller amount of nodes, but that's essentially what we do. That's what we do as an industry. That's what we do as data security professionals, is we secure apps and systems and things and containers. But we don't secure data. Your data is still locked up in those places. It gets shared, but it gets shared badly. You haven't enabled it, and you haven't gotten to the place where you need to be to let your data flourish, because what we end up with is this centralized security policy module or methodology that is created and done centrally, right? But is implemented and interpreted at the individual application and vendor spaces. Netscope has their own version of crypto that they do. It's using standards, but they do their thing. SkyHigh does their thing. RMS does its thing. But they're all independent, and they're all individual, and they're all done separately. And when I sit and they come into my office to pitch their products, and I hear or start to grill them about key management and how they're handling the important aspects of that data, the answers are bad. Right? It's not that they aren't doing it and they're not doing it securely, but they're not doing it in a way that lets me share my data, to move things out, to rotate keys, to swap out vendors if I need to. So my data is still confined in those applications or those suites or those services. So how have I protected my data? We haven't. We're still stuck. We're still using the same technologies, the same methodologies that we've been using for more than 20 years. Where's our innovation? If I go back to this model, I don't have 100 different LDAP directories. I don't have 100 different implementations of access control and authentication. I get SAML. I get OAuth. I get OpenID Connect. I don't have point-to-point encryptors anymore because I have open standards for VPN and TLS. Where's my innovation for data protection? This is what we end up with. Because within a business, you can't get your data effectively shared throughout all the different areas that you need your data and ways you need to enable them. Guess what? Neither can your partners or your businesses or their businesses and their customers. None of them can. So this is the world that we live in. We have all these silos and containers of data. And it's crappy. And the businesses, the ones that we're all here to support, the ones that we're trying to enable because they're the ones that make the money and they're the ones that eventually fund our budgets, are not happy because they just want their data. And despite all of our efforts, we are still just a cost center. Security in almost no organization is a benefit. We're not making money. We're not bringing it into the bank. We're taking it away. So we don't show anything for the value other than hopefully not being in the news. So seeing all that and realizing it from that 50,000-foot level at what I needed to take care of within the bank to really do my job, I had to start over. I had to think of a new way to approach the whole thing. because the past 20 years, what we've been doing all this time isn't working. And so what I try to do is step back and look at what we're trying to accomplish. What does the security policy do? What does it say? And really what it's trying to answer is these 5 questions about data. What is your data? When is it valid? When should people be able to see it? If you're doing a financial report to the SEC, I don't want that data leaked before it's supposed to be leaked. Where is my data valid? If I have confidential PII on South Korean citizens, I shouldn't be able to look at that data from Uzbekistan. It should only be viewed within South Korea, as an example. Who is allowed to look at my data? That's pretty self-explanatory. And the how. What can be done with my data under what circumstances? Those are the basics, right? That's what we're trying to accomplish with our data protection strategy. On top of that, it used to be good enough to just know who has access to stuff. You used to be able to tell the regulators, here's the people who have access to or can change financial data, for example. That's not good enough anymore, because now what they want to know is not just who has access to it, but who is accessing it. Where are they accessing it from? What are they doing with it? The same basic sets of questions from a visibility perspective. So as I'm looking at those pieces, I start to think that if I'm going to have that visibility piece and that awareness of data in every aspect, that I then can get what has to be said in every 2016 presentation is behavioral analytics. So because I have visibility into the who, what, where, when, and how of my data, I should also then be able to act on that data. If I see that Alice got a bad review last week, and the next day she's downloading the customer database and the HR records for payroll, which she normally doesn't do, that's a red flag. So I should be able to act on that. I should be able to do something with that data. The only way I could see that something like this could happen was data protection as a service. So I started trying to come up with a way that you could take this data policy and turn it into action and control. One of the things my boss had asked me to accomplish, and I completely ignored him because I had no idea what he was talking about. He said he wanted human language, machine enforceable policy. And I didn't get it until I started drawing this. And what it really means is I want a central point that not only has the policy and control and rules about my data and everything that goes along with it, but a centralized place where apps and services and devices can ask questions about it, can say, I need a key for this, or I need to access that. So how would that work? On the left-hand side, you would have a data protection as a service enabled thing. A phone, a BYOD device, a server that's processing credit card data, whatever it is, right? A thing. And it would be enabled to support data protection as a service. So if I take the example of, let's say, a Word document, and I'm creating a Word document for my employee base to say, here's what their reviews are, what their bonuses should be, and their raises, and I'm going to send it to my boss. So I just create this Word document, and I just click Save. In the background, the application itself, or the plugin, or whatever that is enabled, says, okay, I see that this is sensitive data, this is HR data, I'm going to call up the service. Hey service, I've got payroll information, what should I do with it? And the service is going to say, okay, I'm going to put these tags on it. You're going to tell me everything I know. So the application is going to say, this is Mike Bass, he's on the network, he's on his laptop, it's 4:02 p.m. and he's in North Dakota. So the data protection as a service now has information, metadata, about the data that was created. It then in turn is going to say, all right, here is key ID number 27, I want you to protect that data. The app is going to take key ID number 27. Note that the app didn't have to generate keys. It didn't have to figure out where to store keys. It didn't have to do any of that. It just asked for a key. The service created the key, sent it to the app. The app uses it in RAM only, encrypts the data, deletes the key, saves the file. So I now have a single key, which has encrypted a single blob of data. In this example, it's Word, but it could be a single cell in an Excel spreadsheet, or a field in a database, or a field in a web application. And it saves it. And now I mail it to Alice, who is the manager, and I say, here's what I want to pay my employees, please check the doc. She opens up the doc, just double-clicking on it. In the background, data protection as a service-enabled app calls up the service and says, hey, I'm Alice. I'm on Alice's machine on the network. It's 4:45 p.m., and I'm in North Dakota. can I have access to key number 27? The data protection as a service takes all that metadata and stores it so that we get analytics and visibility, decides based on policy, is Alice my manager? Is she in HR? Is she on the corporate network? Is it within the time frame that she normally does stuff? And it makes a decision, yes or no. Can Alice have access to key ID number 27? If so, release the key. Key ID number 27 comes down, data is decrypted, RAM only, keys destroyed. Alice now has access and says, oh, look, you messed up. I want Bob to have an extra $1,000. She makes a change, clicks save. Same process. The application says, oh, crap, I don't have to save this, which means I have to encrypt it. I'm going to call up the service. Hey, service, this was encrypted with key ID number 27. Can I have a key? And the service says, sure. Here's key ID number 28. And then the same process repeats. It saves it. Now, something amazing happened there, whether you know it or not. Not only did I just automate key rotation, but I've actually done a lot more. So first of all, key rotation is a massive pain point in any company of scale, whether you know it or not. Anybody in here trying to deal with SHA-1, getting rid of that in the organization? It's a pain. This is solved. If I can give you a new key on demand, anytime data is changed, and I can rotate or change those keys at any time, then my policy decides what crypto I want. If tomorrow quantum computing comes out and I realize that all of my asymmetric keys are dead and AES 256 is no longer good enough, I make a change in policy. If I don't want to use SHA-1 anymore, I make a change in policy. Every key issued from that point on uses the new policy, not the old policy. Anytime data is written, new key. If South Korea says from now on only South Korean data can be viewed within South Korea, and the keys will only live in South Korea, I can either use the old way, in which case I have to change every application I own within South Korea to respect that, or I can use this model and make a checkbox that says from now on, using geolocation, only allow data access to South Korean data, key access within South Korea. If you look at it from the next step up, this is what it looks like. Enabling it within the applications, within the vendor space, across the board. What matters here is the bottom. The bottom is the data. It is not application specific. That data can go anywhere because the key is tied to the data. Not the app, not the place, not the thing, not the container. The data is free to go wherever as long as whatever you have understands data protection as a service. This is not hard. In theory, we could stand up, get some of our 40,000 developers and build this in Citi, but does that solve the problem? It doesn't. Because even if I deploy this completely throughout my organization, I haven't solved it because I've just made a bigger silo. Now my big silo is Citi. I've got all my crap covered, but my data doesn't just stay in my organization. I've got aggregators like Mint and Intuit and whoever else. And we share data with other banks and the government and consumers with statements and mobile apps. So I still haven't really solved the problem because silos don't work. If they did, we'd all be using RMS right now. I'm not knocking Microsoft and RMS, but that doesn't work. It cannot be a single vendor, cannot be a single solution. What we need is a standard. What has to happen is the evolution of data protection, the same way that we had the evolution of ID, of identity and authentication and authorization, entitlements, all of it. Because you don't build those things, you go out and buy it. And you have your choice of vendors to choose from because it's an open standard. What we need for data protection as a service is an open standard, open source SDKs and tools to enable the sharing of data and the understanding of policy between organizations so that a Citi doesn't break the compliance policies of Bank of America, as an example. Currently, I could easily encrypt stuff in a secure PDF and send it to Bank of America people and they could open it. But Bank of America compliance doesn't like that because they can't open it. So we have to have the interoperability and the standard that things can build from. This is the way that things have to go. What we get on top of that is data about data. So it used to be that it was just about your data, right? How do I enable it? But now, I could actually provide a value. I could provide a cost save. Because I have a cryptographic representation, I don't ever see the data, right? Data protection as a service just sees keys and metadata. But because I have that metadata, I have a cryptographic representation. So I can know every duplicate file, for example, in your organization. its usage, where it lives, where it is, how often it's been opened, what's its expiration period, what's its retention, how much money can you save just knowing that? I'm a crypto person, so I don't even know all the value of the data about the data. I just know that it brings up a new issue, which is the next thing that the businesses will then scream for, is how is my data being used and what can I do with it? That was my goal, was getting this level of data protection as a service. And I thought I was hot, that I'd come up with the greatest thing ever. And I was excited about it. And so I went to the venture capitalists at Citi and the various startups that we talked to and said, we need this. This is what we need to do. Find me somebody that does it. I'd never heard of anyone that does it. I didn't think they would find anyone that did it, but they did. And so I met with those people, and I met with those organizations. And as soon as I realized that anybody was even close, I called my boss and said, I'm resigning. Not today, but I'm going to, because this is bigger than me, and it's bigger than Citi, and I want to be a part of solving it. This was my grail. This is what I've been doing since 1989, is trying to solve key management, but in a prettier way that doesn't make it sound like key management, this data enablement. And so after I told him I was leaving, I met with the companies that were closest to solving this problem and found the one that was willing to make it open, to make it an open source and an open protocol that can be shared so that that reality that I showed can happen. And that is why I resigned. Any questions? Yeah. Well, yeah, go ahead.
In that case, how do you indicate that somebody else has got a copy of the data that they have to keep for the retention purposes? They are that employee base in 7 years, but it gets updated, say a salary, and then you have to put it all.
Absolutely, you do. So I'm trying to not delve into specific product information. The first thing I want to make sure is clear is the application that's doing the work, that's encrypting, did not generate the key. The key came from the service. The service maintains all keys. So yes, absolutely, it has to maintain all keys. It has to be a built Google scale kind of cloud solution that covers this. The one thing I didn't talk about, and this should be a priority for anybody, is even though this needs to be a cloud-based service because you have to have things at BYOD and mobile and consumer-facing, the keys themselves should be owned, controlled, and in the possession of the organization using it, right? So if Citi stands it up, sure, there's a cloud service, but there must be an on-premise key service. So keys stay here. Cloud service cannot have access to the keys, period. They can orchestrate, so a key can be encrypted from here to Alice and pass through the orchestration, but the orchestration engine, the cloud service, cannot have access to the keys. But yes, it's a massive key database. Yep. So that's all stored with, this is product now, right? So I can only talk about specifics of product. The company I now work for is solving this. They are most of the way there. There's a couple pieces I'd like further, like the open source bit, but it's coming. Essentially, the way that it works is every piece of data is tied to a key. Every key has a key ID. The key ID has, I believe, a 64-bit key space in the name, which means the key ID supports 1 trillion keys per user tenant. So a single tenant could have a single key space that supports 1 trillion keys. You can have multiple key spaces. So that data and that logic is all within the data structure. Any other questions? Yep. That is for a much more complicated slide that I don't have with me. There is a registration process that takes place. It's something we call verified blind exchange. And so when that registration process happens, there is a sharing of secret keys between the endpoint that's being registered and the on-premise, right, the Citi owned in this example. Now, just to be clear, Citi didn't buy this yet or anything like that. I'm just using them as an example. And that registration process does a key sharing. Separate to that, after the registration process, so now your on-premise has a key, your agent has a key, they can now encrypt data for each other. There is also an additional pipe. So everything is done over SSL, TLS, but there is also an additional AES pipe that is created within the TLS tunnel to prevent man in the middle. So if you stood up a blue coat, for example, in front of it to do SSL inspection, it's not going to see it. And even if it did, the data within the pipe itself is also encrypted to the key that the agent has. And vice versa. When the agent has to send its metadata back, it's encrypted to the on-premise. Separate to that, there's another key agreement basically between the cloud service and the on-premise key services, and the cloud service and the client key service. I know that's a lot in a single answer. Anybody else? Okay, thanks. I have no idea how early we went.